Hello everyone, Energy Crafts here. If you saw part 1, you saw my proposed ultra solar hot water batch system. This is part 2, and this is the implementation of that idea. And happy to say that it works really great and incredible. So let me give you a walk around first of what it looks like. I took the parts from the original batch hot water system and cannibalized it in order to make this system. So here's the hot water tank I had originally that was painted black, and I reassembled it and put it back close to what it was. There's insulation that I've added to the sides where I had taken the original insulation off. The system here consists of basically an insulated box and the pool solar panels put inside. Again, it's about 12 foot long and about 4 foot wide. And there's nothing special about it. One of the things I wanted to point out is we don't want to super insulate the enclosure because the sun gets so hot that we'd run the risk of melting the plastic pool solar panels. So to alleviate that, I've purposely left holes here and there to have some natural ventilation. Like this part right here, that's just some aluminum metal siding from a house, just a scrap piece. I've got that sitting there. It really only serves the purpose of keeping rain from getting inside the box, but really otherwise it's just cosmetic. And in the wintertime it's nice to have it on it because it helps to contain some of the heat, but in the summer I can take that off if I want to. And the same thing in the sides of the box. These are actually screwed on little 2x4 sections, and I can remove those sections if I find that this box is getting too hot in the summertime. The piping down at the bottom, that's 2-inch PVC, and it goes to this section goes to the bottom side of the solar panel. And of course I recycled and reused the two glass sliding door panels that I had used on the batch system originally, and so I'm just reusing them here. And at the bottom I've just simply put a lot of concrete blocks to help keep those heavy sliding glass doors from sliding off if it got real windy or something. And then on this side, basically the same as the other side, there's the removable screwed on 2x4 sections that I can take off if I find that it's getting too hot during the summer. This is the upper 2-inch PVC connection that goes to the panel, and this would be the hot water out, and it's going in an upward angle. As you can see, it's inclined upwardly through a valve and then straight into what used to be the upper element of the hot water tank. At the top I've kept the pressure relief valve, so everything stays nice and safe. The lower PVC is the colder water section that goes to the what used to be the lower element porthole of the hot water tank. Now that is the full cycle, closed cycle right there for the heat from the sun rising up these the tubes. If you can see those inside, those horizontal tubes, they all go to a common manifold at the top, and then as the hot water rises, it goes to the left and then it continues up this pipe and then continues up through the valve and into the body of the hot water tank, and being that it's lower density than the colder water at the bottom of the tank, it keeps rising. And as it does, by displacement, cold water keeps returning back to the pool solar panels to continue the loop. So that would control the getting hot water into this tank. But how do we get it in the house? Well, that's easy enough as well. Since hot water rises, I'm tapping off of the upper section of this hot water tank, and also using an upward inclined path. The hot water continues to rise and thusly flow up this pipe. And this section is CPVC, and it slowly rises, continues to rise. There's quite a bit of incline right there. And then the upper pipe goes in the house, which is the hot. Now looking down below, you can see I have the return pipe, which is the cooler water returning, and of course it goes back to, follows this pipe, and then it goes to the well, in this time I've got it going to the drain at the bottom of the tank. I could have gone to the lower element port, but it was just as easy to do it down here. Plus I get to use the extra valve that's naturally comes with the water tank. Excuse me. So that's really all there is to it. It's the whole goal of this was to have a simple automated system powered by the sun, and I think we've achieved that. No computers, no electronics, just an automatic system giving us free heat and paid by nature. Alright, I'll take you inside, and if there's enough light you can see my existing unchanged hot water tank inside the house. And the only reason we're using two tanks is because the tank in the house is kept original, so that if there's no sun for several days, I simply can just turn the hot water tank on and it works just as normal. But you of course have to close the valve out here to isolate the tank outside. But most of the time when there's plenty of sun, we don't need to power the indoor normal tank, and we can just simply rely off of this. And so in effect we'd have two tanks that we can couple either in series, parallel, or one or the other to deliver hot water to the house. Okay, now we're in the house, and this is the regular hot water heater indoors. It hasn't been altered except for bringing in the two lines from the outside tank, which I'll show you here. Here is the upper line that's coming from outside and going to the side of my regular tank indoors. This was where the pressure relief valve used to be, and all I did was bring out a nipple and re-hook on the pressure relief valve, but tee off for the pipe that's coming in. This pipe here is the hot water coming in from the solar panel outside, and so all the hot water will come to the top of this tank, and slowly this tank will become full of hot water. The returning cooler water is at the bottom, and I've simply just tapped out of the drain line, and that's the return going back to the solar system outside in order to be reheated again. So and then I have a valve here that I can secure it at night, due to the fact that I don't have a check valve. Now, if you had, I'm a bit limited on income, so I can't afford to have check valves right now. So in the meantime, I'm just simply using a regular ball valve, and I just remember to turn it off as soon as the sun is no longer producing much heat, that's when I turn it off. And this is a 50-gallon tank, so that's plenty of hot water for me for the night. Alright, now I'll give you some measurements of temperature. So a typical temperatures to expect that I've seen so far, I've been using this since the beginning of January, so I only have January, February days to back up my information, but so far what I see typically is anywhere from 20 to 35 degrees above whatever the air temperature is outside. That's the temperature I'll see in the tank. So as you can see, today is pretty cloudy. There's not a lot of sun. There is some, but it's here and there. It's very skimpy. So let me make some measurements. So at the very top of the hot water tank, which should be the hottest water, I'll take a measurement. Right now it says something like 106. Earlier I had 112. And just for fun, we'll look at where the hot water is going into the tank. And looks like there it's a 100. Oh, it is 112. Okay. So there's a little bit of difference in temperature depending where you measure on a tank, and also the fact that you're using this infrared type of measuring device. If I measure directly right out of the solar panel, right here, heat Celsius, here we go, Fahrenheit, reading 107, but it depends on where you measure, because it'll be shifting around. Obviously, since I'm measuring the outside temperature, the inside of the pipe would actually be probably several degrees hotter than this. But mind you, this is a very cloudy time right now, so I think it's pretty good that you can get these temperatures with as much clouds as I have. Alright, well, there's the only thing I can mention more is to improve this system. There is always room to improve any system. The thing that I would improve on this one, if I was going to do it over, well, let me say this. This was only meant as a proof of concept. It wasn't meant to be aesthetically pleasing and beautiful and all that. It was just to prove a function and prove a point that it can work automatic by itself. So, but if you wanted to improve it, there's a number of things. One is I could have brought the panels closer to the wall of the house. The other thing is I could have tilted the panels more closely to the correct angle for this time of the year, which approximate is good enough for me. It's only hot water. We're not trying to run a steam engine. These solar panels are made out of plastic, so you can't go crazy temperatures. You have to be reasonable. The other thing that I would improve is I'm still using a valve here at the bottom because I don't have the funds to be buying check valves. And for thermosiphon, the pressure is so low that a regular check valve that you buy at a plumbing store would not work. We're talking a tenth to a hundredth of a pound of pressure, so regular check valves would not work. Like in the pool industry, check valves would not work because it takes a number of pounds of pressure to push it, and this is nowhere close to that. So it's no big deal for me to come out here and close a valve here and there. If you wanted to get rid of the check valves altogether, the real simple solution is simply to take this water tank and elevate it above the very top of the solar panel. For me, that's means building a tower, and it'd be quite high up in the air. So, and it cosmetically, people would consider that pretty ugly, so I didn't do it. But as long as you have the tank at least level with the level of the solar panel, the thermosiphon will continue to work. It just will work a lot better if you raise the tank up higher. So the bottom, ideally the bottom of the tank should be above the top of the solar panel. And that's about it. That's all there is to it. And the same thing is true for my tank inside the house. If I wanted to do better, I would increase this incline by raising the tank in the house. But it would be a monster to be raising it higher. And 4 foot higher up off the ground would be quite high. So I haven't done it. And it's working the way it is, so we're okay. Alright, well, thanks very much for watching, and I hope you enjoyed this. Peace and out.